Welcome back to another Taproot podcast. Today I've got Emily with me, and Emily, we're going to be talking about the most dangerous jobs in the world.
Yep.
Now, you wrote an article on this of the 10 most dangerous jobs. Where did that list come from?
Well, contrary to belief, I didn't just have an opinion piece here. I did some research, and I looked at a lot of different sources, OSHA, CDC, looking at a lot of different areas to come up with this list.
So, a lot of different sources. I know I've seen several different ones. This thing changes a lot each year, obviously, because every year there's a slightly different order. But I think this top 10 has been pretty consistently as far as some of the most dangerous jobs. I think for the purpose of this podcast, we don't want to just say, here's 10 things. I think we want to talk a little bit about what makes these jobs dangerous and kind of some of the controls that should be in place but often aren't, but might need to be in place for some of these jobs. So start us off. What's the number one, top of your list of most dangerous jobs?
Well, according to the U.S. Bureau of Labor Statistics, BLS, that is logging workers.
Logging. So I've actually, had the privilege of working with clients that are in the logging industry, and it's pretty dangerous. I know of a couple fatalities that I've been, familiar with, not involved with necessarily, but familiar with. What do you think makes logging so dangerous?
Well, the hazards are falling trees, heavy machinery, extreme weather. That's coming from the BLS, saying that 97.6 deaths per 100,000 workers. So, I mean, those heavy trees, if you've ever seen a tree fall, it, boom.
So I think that's something that's hidden to a lot of people. When you think about the hazards, and I got one of the clients I worked with, they gave me this pocket field rigging and tree felling guide. And it kind of goes through what are the main steps of tree felling. And one of the things it talks about is calculating. It's got a whole thing on calculating the weight of a piece of green wood, which is surprising to me that it's as heavy as it is. And if you've ever worked with trees, they're heavy. So it's got a whole chart that it gives for things like based on the length and the cross section. So what is 1 foot? So if we cut a tree and you had 1 foot section of it, how heavy it is. If it has a 10-inch diameter, I mean, that's not massive. That's 25 pounds. For 1 foot, 10 inches, 25 pounds. When we're thinking of like a long section or a really big tree, if this is like a 26-inch tree, we're already getting at 1 foot is 145 pounds, and that's of alder. Now, again, every tree is a little different. There's some that are heavier than others. We get things like, I just go down my list and see hickory. We're talking a much heavier, certain type of hickory. It's going to be a heavier tree.
Yeah. I had a 100-year-old silver maple in my driveway that it was diseased, and so branches were falling off. It was so bad I had to have neighbors help me pull the branch out of the way so I could get out of my driveway.
Yeah. So, the weight of these trees are enormous. We're dealing with a lot of, I'll call it potential energy buildup. So when we think about what makes jobs dangerous, we want to look at energy. For Taproot, we're thinking about hazards. That's a source of energy. So in this case, you've got a massive amount of potential energy stored really high up. That creates a lot of opportunities for people to get hurt.
Makes me think of your energy wheel.
Yeah. Not my energy wheel. I did not create the energy wheel.
The energy wheel that you use in class.
Yeah, a lot of people use the term sticky. You ever heard of sticky? So it's stuff that can kill you. So when you look for hazards, you're looking for stuff that can kill you. And in this case, the tree, the weight and massive amount of potential energy in that tree, that can kill you very easily. That's one of the reasons why they cut certain sections, because once you get over a certain weight, it becomes very difficult to handle. Other kind of things that are hazards, when you think about trees, all trees are different. Trees have hidden dangers in them. Maybe there's fungus. Maybe there's some sort of cavity that happened from something. So there's all sorts of like hidden hazards inside trees. So I think when we identify these hazards, we also need to think about what's the safeguards and what kind of safeguards are present. So with trees, what would you think is the number one thing where it's going to what?
Fall.
Yeah, where it's going to fall. And so they call that the danger zone. So if you're felling a tree, you've got to have a danger zone of where that tree is going to fall. There's good sides and bad sides for falling. So, have you ever seen one of those videos of somebody who was like cutting down a tree next to a house? And of course, if it's a video, you know exactly where it's going to fall, right on top of the house. So you got to think about which ways it's going to fall and plan that danger zone properly. Where are people going to stand and be around it? If it's a really, really tall tree, they're going to do it in sections. So that's going to have a guy climbing up there. You see them in their straps. They're hopefully appropriately tied off on the tree. And I remember seeing a video. They were cutting the tree, and they had the log tied off, or what became the log. As they cut it, it swung back, hit the tree. The guy was properly long, but he went on for a ride. You could just see him hit. He loses his footing, and he's kind of dangling there and has to get himself back up. Again, anticipated, right? They knew it was going to fall, but maybe they didn't intend it to hit that way or fall in that manner. So there's a lot of energy that you're trying to deal with and control and guide in these type of this line of work. So there's one final one, and I want to pass this one along as well because it's a common. The acronym is MAD.
Okay.
Now, that probably pops a million different acronyms up in your mind, but MAD stands for minimum approach distance. What do you think they might be approaching?
Other structures.
So it's specific to power lines.
Okay. Yeah, that's a big one.
So again, when we think about logging in industry, most of the time they're getting hurt from falls and getting hit by the tree, right? Those are the leading causes of injury. But one of the other things that's really dangerous with it is power lines. And there's a ton of logging work that happens around power lines because we have to keep them clear of trees. And so there's a minimum distance you need to be away from a power line. And a lot of times when you're cutting trees, at how you approach and do that cut and where it falls, all of that has to be taken into. So it can be, a really heavily knowledge-based decision kind of thing of making these assessments for every tree is different. Mm-hmm. So I can see why that one falls in that number one category. Yeah. What's our number two?
Number two, commercial fishermen.
Whew, fishermen. Mm-hmm. That's a famous show there, Deadliest Catch, right?
Yeah, I've never watched it, but yep. Unpredictable weather, vessel capsizing, dangerous equipment, 100 deaths per 100,000 workers, according to the CDC.
And what do you think the number one cause of death is? What would you think? What would be the number one cause of death?
Drowning.
Yeah, not surprising. That it's not even close. It's not like there's the secret killers, snipers on
shark
the sea.
Bite.
Yeah. It's not pirates. It's not sharks. But it's drowning is the number one. And when again you look at some of the interesting things with the data on this, a lot of like commercial fishing vessels, they don't wear life jackets.
Nope.
And it's because that industry globally, we think of like the Alaskan fishermen, but that's a global industry. There's people that have been subsisting on fishing for as long as people have been around. Mm-hmm. And so a lot of these vessels aren't fancy vessels. So if someone goes overboard, if they're in a storm or in high seas, they don't have their jacket, they're gone. Mm-hmm. And you don't see them again. You mentioned vessels. What was the statistics on vessels collapsing?
Capsizing. It doesn't. It's just general hazards.
So one of the things I was reading about this was one of the common causes of that. And again, when you look at drowning, obviously falling overboard is one. But when a vessel is hit, people fall overboard, but also the vessel can get flipped up, and it creates a dragging force that pulls people down. And so if you're slightly under it, you're getting pulled deep underwater, can't get back up.
And it's deep sea fishing, so
If it's deep sea, or even, I mean, it doesn't have to be that deep for that to be a big problem for people.
You can drown in like less than a foot of water. So.
So again, we think about what kind of things lead to vessels capsizing. Storms is one of them. Another big one is actually getting hit by another vessel.
Or maintenance, lack of maintenance.
Lack of maintenance could be a hole in there, but one of the biggest ones is actually just getting hit by another vessel. So when we look at things like, what are some life-saving controls, you wouldn't have thought for fishing that it's having accurate weather data and having a radio that you are communicating with other vessels, like how critical that is. And I would think you wouldn't go out to sea without checking the weather or talking to other vessels. But again, it's a global fishing industry. And some areas you have a lot less regulation, a lot less requirements for some of these life-saving things like life jackets, radios, and real-time weather data. And so those kind of things can lead to people falling over line, getting pulled over by equipment.
So we've talked about getting some logging and fishermen issues here. The next is aircraft pilots and flight engineers.
So what's your data from the aircraft pilots?
Well, it puts it together in one category from the International Labor Organization that the hazards are equipment failure, extreme weather, fatigue, and mid-air collisions. And the fatality rate is 58.4 deaths per 100,000 workers.
Yeah. Now, this one obviously, not to date the podcast, but the timing on this one is...
I wrote it last year. Just saying.
I know. and yet this year, what's one of the biggest topics is
mid-air collision.
A mid-air collision in the U.S. So when I think of this one from a hazard standpoint, what do you think? What's the biggest hazard you've got when you're dealing with an aircraft? This could be helicopters or planes. We think of this, is it motion? Is it gravity? Is it what's going on?
All of the above.
All of the above. So a lot of times from a pilot standpoint, we think of wind speed, right? Or airspeed. If I'm not moving this way, or in a helicopter, my blades aren't doing this, then I'm doing this, because I'm always under the force of gravity. It is always pulling us down. So we've got to be making sure that the plane has to be moving, or the blades have to be moving, because otherwise we're falling. Maybe you're falling with style, but you're falling. And so that's a really important thing, is you're dependent on your equipment. If your equipment is not functioning, that means you don't have the force to go this way or this way. You're going this way. And so one of the leading causes, there's two big ones, and you get equipment malfunctions, and the other is pilots taking off with known equipment malfunctions. So they knew there's a problem and they still take off. And those things lead to a ton of basically aircraft failures, where they're having something happening that's causing them to lose thrust, lose some sort of control of the aircraft, and it results in the vehicle going down. I found this one, and I don't know about you, but I found this one really hard to research, because anytime you look at like leading cause of aircraft failure, everything comes up with human error. Everything I see comes as human error. That's where they start.
The pilot. Yep.
It's all the pilot's problem. And while technically true, it does have a human error element, it's really not a very good way of defining causes. Of course, someone made a mistake. We wouldn't be talking about this if somebody didn't. So just saying pilot error and human error, I found really unhelpful when it came to trying to research data for what are some big causes and some things to look for. For me, I think one of the biggest things from a airline standpoint is making sure that your pre-flight checklist is followed. From commercial pilots and commercial airlines, they're very good about this. When you get to more private, when you get to the smaller, we're talking like the single people getting hurt on their little ultralights and things, you start to see less robustness in checklists, and that's where people are making judgment calls of, oh, I think I can fly anyway, even though this isn't properly functioning. Those are the kind of things that you see a lot more of at the lower scale stuff.
All right, so we got splinters and sunburns and skies. Moving on to roofers, number 4. So roofers' hazards, obviously we know about falling. So falls from heights, slips, extreme heat, exposure to hazardous materials. Fatality rate is 51.5 deaths per 100,000 workers. And this is from OSHA.
And this was an interesting one too for me, because I was looking at the data and I was like, what's the cause of fatalities? It's unsurprisingly falling, right? And it's not even close. And it's like, all the rest of it can fall into, heat exposures, electrocutions. Those existed, but it's like falling was, the largest. And you'd think, roofers, that they should be really aware of that hazard. But when I was looking at it, there was a couple things that popped up. The majority was people falling off the edge of a roof. Again, probably not surprising. But I also thought about things like skylights. There was things like openings. And I had a client in a course not that long ago. They had it wasn't a roofer. They were actually working on solar panels on top of a facility, and they were cleaning them off. And as a part of their procedure for cleaning them off, they needed to take a picture of it. And when they did, they unclipped from their fall protection and they stepped off the edge to get a better shot. And when they did that, they stepped through a skylight. They couldn't see it was a skylight, but they stepped onto it. They dropped, I want to say they dropped like 25 feet, and they landed on concrete. Not a great place. It wasn't a fatality, but this person was severely injured because, dropping any number of feet onto concrete, not fun. But just things like that, when we think about wearing fall protection, you'd think it would be obvious. You're working at heights, wear fall protection.
Common sense isn't so common.
Well, I don't know if it's necessarily about common, but it's things like, where do you tie off? So I think of like roofers on my house, where do they tie off to? There's not a clear anchor point sometimes. And they're just up there just, putting in shingles or something. So having a clear tie off point and ability to move around. Have you ever seen there's a famous, I think it was a joke picture. I hope it was a joke. The guy who was tied off with a rope around his neck.
No, I haven't
and it's
seen
like
this.
that's fall protection. You're only going to find one. You're only going to use once. So it's like, where do you tie off? How do you properly tie off? That comes into play. But also things like, how do you mark things like skylights or other openings on your job site? Again, I could think of another client I had. They were doing construction, and the worker left. They had a designated area they were supposed to be working in, and the worker then violates that boundary and goes walking off. I don't remember what they were grabbing. I think they were picking something up and moving it, but they were walking, and again, they violated boundaries and stepped onto a skylight or an opening they stepped into and fell. And so you see these things happen a lot, where even if you had fall protection, it gets unhooked so that they can go do something. So again, you've got to think about that positioning. How do you have the mobility you need when it comes to something as simple as fall protection? Can be pretty complex.
And a lot of this doesn't specify whether it's an inexperienced worker or somebody who has more experience who maybe already knows these kinds of things. So it's the data just gives us the figures without more detail.
Yeah, you don't have that context, because we know errors can happen to anyone. So you've got to look in and understand the context. Just knowing what's the most dangerous job doesn't necessarily tell you what's dangerous about it or what we can do. What's our next one on here?
Structural, iron, and steel workers. The hazard, falls, heavy machinery accidents, and structural collapses. Fatality rate is 41.5 deaths per 100,000 workers, and this is from the Bureau of Labor Statistics.
Now, is that the guys with the lunch boxes sitting on a steel girder?
Lunch from a skyscraper is a pretty famous image, but yeah, structural and iron, we have a lot of those in our area too. So it is definitely dangerous for how heavy it is, but I mean, I hear it pays well.
Now, I was looking at some of the data on this one. And obviously they have falls too, because again, you're doing steel work, you're working at heights a lot of the time. So the falls definitely comes up there. But dropped objects was one that was common that you didn't see in those other three. I mean, you do with dropped objects being a whole tree, but this one was head injuries, things like that. They had a lot of injuries from dropped objects. And, that always makes me think about, how much force. There was a video I remember seeing which was comparing if you dropped it was a metal bolt. And you could watch it, I think it was in slow motion, which is always the best way, but you'd watch it fall and it would hit one of those fake heads that looks realistic with a little skull, one of those gel heads. It hit there and just plows through.
It's something similar, but I think maybe it was like the Empire State Building and a penny or something from some high rise, and the force and just something so small, but.
So there's a lot of force that can go through there, and you've got the hitting the guy's head versus if you had a hard hat on. And it's crazy what a proper hard hat can do for protecting a head. Same with things like steel toes, just for protection. I thought an interesting other one with this was, again, you start seeing things like amputations. Because, again, anything in construction, heavy tools, heavy machinery, there's a lot more energy starting to be involved in this.
And the fact that we're talking about structural steel, I mean, that just the weight behind all of that it might need to be further up the list. But again, like you said, things can change. This was from last year.
Yeah. So what's our next item on here? Surprisingly,
but the more you think about it, maybe not so much. Trash and recycling collectors.
Yeah.
I saw a video recently. It was like a sanitation worker, and they didn't realize there was an oxygen tank in the trash. You're not supposed to throw that away, and kaboom. So, I mean, the things that are in the trash, we've got, for one, vehicle accidents, people who aren't paying attention to the trash trucks coming through, heavy lifting. I tried to put a couch out, and they said it's got to be shorter than 6 feet, and 2 people have to lift it. And I'm like, yeah, that's okay. I'm going to have to haul that myself. And then exposure to hazardous materials like the O2.
Yeah, we had some trash and recycling clients as well, and the number of battery fires that they deal with on a regular basis, whether it's in the trucks themselves or a lot of times when they get it to wherever they're trying to dispose of it at, whether it's like they'll do there's fire, they use trash for energy. It's a very common way to use that up and use as a source of fuel, but they deal with fires all the time, and battery fires are pretty dangerous. Obviously, though, again, this one, you look at the data, biggest is vehicles. You got guys standing on the side of trucks or guys working in there, driving vehicles. You're going to get hit by other vehicles because people are not paying attention. And, that's one where it's not the job itself, it's the job in its proximity to other people and driving dangerous.
And the fatality rate for this one is 34.9 deaths per 100,000 workers, and that's from the National Institute for Occupational Safety and Health. So next,
watch out for trash trucks and the people driving them and working on them.
That's a tough job. Miners.
Miners
is next on the list, and that's miners, miners, people who work in cave-ins, toxic gas exposure, explosions, and lung disease, and the fatality rate is 25.7 deaths per 100,000 workers, and that's according to the Mine Safety and Health Administration.
Yeah, I think we've come a long way since the canary in the coal mine days as far as hazard and recognition. I think, again, this one's pretty straightforward when you think of proximity to heavy machinery. There's a lot of different types of mines in the world, whether you're going subsurface or not. There's, a lot of famous cases of people getting buried and recovered and those efforts. I think something that's interesting is just the amount of weight that dirt has.
Yeah.
And there's a lot of, whether you're talking about trench work or something larger, there's tons of things where you can see people will suffocate when you can still see their head just because of the weight and pressure of dirt. Like, I've seen, there was a guy that got buried up to his, chest, and they were able to scratch around. You could see his head, but he still couldn't breathe because the pressure of the dirt on his chest was too much.
In there. I saw something else recently. It was from 2023, and I can't remember if it was America or not, but there was a woman who went to go look for her cat, fell into a sinkhole which was 30 feet into a mine, and she was elderly, and it took several days to find her, and unfortunately she did not make it through that, but falling into a mine of all things on top of a sinkhole, it's like, wow.
So I can think of two mining related stories that I find interesting for this when we think of like hazard recognition. One of them is used as a quintessential training tool for management of change. And the idea was they had this intersection on a mining site. And one of these routes, they have the really large mining trucks. I'm talking the ones that are like, you look up and you're like, oh my goodness, this thing is like a 2-story mining truck, giant cat trucks kind of thing. And that they would use this route to carry heavy loads through. The other had a lot of other utility kind of trucks, water trucks, people driving just normal standard trucks were cutting through. Well, the way the stop signs were configured, the big, giant mining trucks were having to come to a stop. Well, as you can imagine, those things are big, take a lot of momentum there to stop. Well, they decided, you know what, we'll just swap the stop signs so that these things have right-of-way and the others stop. Well, when they did that,
You got to learn that if they're used to the stop signs being in certain places, now they've changed it up.
Yeah. So they're alert. They had some signs they put out. Stop signs changed. What I don't remember what the exact term they had for it was, but it's like the cross area just changed. Be alert. And then they had the stop sign, obviously. Well, these guys were used to driving the path they had, and they didn't have a briefing where they rolled out that they had changed this to all the shifts. And so what happens was there was a water truck that was coming through, and there was a big heavy mining truck going at the same time coming to this intersection. And this guy knew about the change. This guy didn't. And so he's thinking he's going to stop. He's thinking he's going to stop. And again, it's a tire the size of the truck you're driving hits into you. Luckily, they were in Australia, so they're on the wrong side of the vehicle. But that worked out where the tire didn't crush the cab; it crushed the other side as they came together. So, again, those are interesting parallels when we think about which ways trucks hit and how we manage change in facilities like these to alert people of changing conditions and alert them of hazards. So that's one of them I always find is interesting. Another one was and I won't cover this whole story, but it was basically they had a mining cart that was allowed to fall off and land on top of an elevator full of people that were coming out of the mine during a shift change. And it's an interesting story, but there was a series of not just one failed safeguard. They had put best practices in place because they had something close to this almost happen. And so they realized, we need to put all these safeguards in place. Like there's supposed to be it's basically this metal pin that blocks the track. Well, that had gotten removed and pushed to the side. And there was these other things that were supposed to have stopped it. There was like 4 or 5 safeguards that had been in place, but had failed or been, removed to allow something that. So anytime you've got a lot of safeguards in place, you really need to make sure your management system is ensuring that they're in place for these kind of hazards. So what's our next dangerous job?
Well, we have 3 left, and you already touched on truck drivers a little bit. So we'll go back up to agricultural workers, and that is a hazard of heavy machinery accidents, pesticide exposure, and extreme weather. From the CDC, the fatality rate is 23.1 deaths per 100,000 workers. And we have truck drivers, the hazard of fatigue, long hours, highway accidents, which you were just talking about, and hazardous cargo. And the fatality rate of that is 22.1 deaths per 100,000 workers from the Bureau of Labor Statistics, which leaves us with something else you've talked about, which is electrical power line installers and repairers. And the hazard is high voltage, falls from poles, and electrocution risk with a fatality rate of 19.5 deaths per 100,000 workers from OSHA.
So I'll state those are 3 really different ones, aren't they? Field work, again, proximity to heavy machinery. That's what puts the biggest hazard in there is visibility of the drivers and location of people in those zones. That puts people at a big risk. So again, having clear communication and clear visibility when people are in, the path of or in the place of heavy machinery is probably the biggest on some of those. Same with work at heights too for some of those cases. Truck driving, I want to cover in this one fatigue.
Yeah.
That's a big thing in the trucking industry.
Wasn't it like 8 hours? You can only drive for 8 hours unless you have like a 2-man or more man or man and woman team.
There is lots of regulations on driving hours and a lot of things related to making sure that people have proper breaks for driving and getting time out of there. And I can't stress enough how important it is. But one of the things when we think about drivers, fatigue management is important. And I think a lot of trucking is doing things now where it's looking at things like eye tracking, facial tracking to notice when people are, falling asleep or getting distracted. So, cell phone use and other things. All of that is to say that's helping the driver themselves stay awake. But you're also, as a truck driver, you're dealing with crazy people on the road who their company's not involved in this. This is just them,
Just on their daily commute. And we already should know that it takes a lot longer for like a 18-wheeler, a semi, a tractor trailer, whatever you want to call it, to stop. But I'm a passenger in a car, and I'm seeing people like putting on mascara, driving down the road, reading. Somebody was reading, I don't know what kind of book or magazine, driving the vehicle. This is all while driving. And then you think of all the other people on the road, and then these truck drivers that if they've got their own distractions with everybody else and their distractions, and just the recipe for disaster.
Yeah, so that's definitely a high skill and a little bit of luck needed to do well in that. When we, in our human engineering course, or our Stopping Human Error course, one of the topics that we talk about is automation and attention. So when you look at human drivers, the big topic nowadays right now is artificial intelligence and self-driving. So you get a lot of the Tesla stuff for self-driving. One of the things that they think about and talk about is what is the role of the person in these automated systems. You've got a person that's sitting, they're watching things happen. How do you keep them involved? So like my car, for example, I got a Tesla, and if I am on autopilot, I can't look at my phone. If I'm looking down there, you got to have your eyes on your road, which I always find funny because, I could look at my phone without the autopilot on. So I can look at my phone when I don't have something else looking at the road, but I can't look at my phone if the car is watching the road, which I thought is a little backwards in the long run, because in that the goal is to not have it where I have to pay attention. That's probably the end goal we want, for things to be smart enough that you can trust it. But that's a good example of, again, how does automation keep a driver involved? Is, okay, you're supposed to be monitoring the system. You can't be distracted down on your phone and be monitoring the system. So keeping people alert, keeping people involved in the process, even in an automated system for driving, is going to be required.
I think we could just go on a tangent about self-driving vehicles and autopilot and all that. That's probably for another...
It might be another podcast right there.
Oh, goodness. That just sounds dangerous in and of itself.
Well, and we know that people are dangerous drivers, which is why truck driver is up there. One of the things, and I remember hearing that first because I saw it was what's more dangerous, a pizza delivery driver or a police officer. Now, granted, it was intentionally inflammatory, but they get pulled into transportation drivers as well. So I don't think it's that pizza delivery drivers have the most risk, but transportation is certainly a dangerous one from there. What was the other two you had?
That was it. Agriculture workers, truck drivers, and electrical power line.
So the very last one, electrical power line. We've touched on a little bit of this, of the dangers of electrocution and power. We've had a lot of utility workers in ours, and I cannot stress the importance enough of using a bucket truck whenever possible. So I will state that at the front. There's so many incidents that happen because when somebody's climbing up on a pole, there's so much more that can go wrong from their proximity to danger, as well as how they have to be tied off, let's say, in those positions. So when possible, use a bucket truck to position yourself at an appropriate distance there. When you're having to work with the really high risk, I don't know if you've ever seen the helicopter pilots that do helicopter repair work. So on the big utility lines, they'll fly up a helicopter up there, clip off of that, and do work on it from a helicopter. Those are wild as well to see some of those higher risk jobs. So make sure that you're following those proper hook-off positions, as well as keeping the conductor and the neutral in mind so that you're not creating those arc flash potentials.
Now, when I wrote the article, there were some comments that came through. What about this? What about that? So we have to remember that this is not an all-encompassing. There are plenty of other high-risk, dangerous jobs that are out there. And every job has its potential risks. I mean, I could just spout off a couple right off the top of my head. But reinforcing the safety, it doesn't always fall primarily on that worker. It is a collective effort. So when we look at the responsibility, we're talking about the employers, the workers, and the people around as well. When we, in my profession, it's kind of if you see something unsafe, everybody has the ability to speak up and call that out. So
I think
we have to remember that safety is everybody's responsibility.
Yep, and from a company standpoint, you've got to make sure as a company you're looking for the sticky stuff, the stuff that can kill you. You're putting in place proper controls of that energy, and that you're auditing that to make sure that those controls are working appropriately. One of the sessions at the summit that I'm going to be doing a talk on is knowing when you're ready to start. And that's part of it, is understanding what's the danger, what controls are essential and you must have in place to protect you from that stuff that can kill you, and how do you make sure that those are controls that you can audit and follow up on, because a piece of personal protective equipment does no good sitting on a shelf. It's only good if it's on your body. Same is true with any control. They've got to be in place. They've got to be monitored. And we've got to make sure that people understand why they're important.
That's good. And just remembering, too, that the PPE is not a catch-all to prevent, I had my PPE on, I'm good. That you still have to use there's more than one safeguard. There's other things that we have to utilize, and not just get into the motion of doing things and thinking that those things are going to work when we need them to. Sometimes they do, sometimes they don't.
Yep. Tim and I had a great discussion on talking about for corrective actions and control of energy. If you're interested in this one, that's probably a good podcast to go to next and think about how do you...
And what's it called?
That's, I don't remember what the title is, but if you look at our Taproot podcast, that's probably the one right before this one. They can go check out.
Alex and Tim.
I think there'll be a link down below. For...
Something about corrective actions.
Yes, if you look for something about corrective actions in the podcast, you'll probably find it. But it should be in the link down below to find other Taproot podcasts. So with you guys, thanks for joining us for this conversation on the world's most dangerous jobs. Again, check out below for more information from Taproot, as well as comment if you think there was a more dangerous job that should be on the list. Comment that down below. If there's any controls that we should have talked about in these dangerous jobs, put those in the comments. This is a great place for people to share what things are dangerous and what things will keep people safe. We'll see you guys again for the next Taproot podcast.